So a bit about me. My name is Ferros. I'm the founder and CEO of Socket, an open source supply chain security company. I'm also an instructor at Stanford, where I teach the web security course. I'm also the author of hundreds of NPM packages, and probably the two you might have heard of are Standard.js, which is a community JavaScript style guide, and WebTorrent, which is a BitTorrent client that works in the browser. In the past, I was a board member of the Node.js Foundation, which is now the OpenJS Foundation, which was a little while ago, but good time. So what are we going to talk about today? Here's the agenda. So we're going to do a story of a supply chain attack, and we're going to go into some example attack code so you can get a sense for what does a real attack look like inside of an open source package. Then we're going to talk about why are there so many of these attacks happening now? How does an attack actually work? And finally, steps you can take to protect your app. So let me tell you a story. On January 13th, 2012, over 10 years ago, a developer named Faisal Salman published a project called UA-Parser.js, a user agent string parser. Lots of people found it useful. After 10 years of steady work, he continued developing the package with help from many open source contributors, and he published about 54 versions. The package continued to grow in popularity, eventually reaching 7 million downloads per week, and being used by 3 million GitHub repositories. Meanwhile, on a Russian hacking forum, this post showed up. So this is a hacker selling the password to an NPM account that suspiciously has around 7 million weekly downloads. So you can see here the asking price is around 10K US dollars, and you can buy it now for 20,000 US dollars. So 2 weeks after that post appeared, UA-Parser.js was compromised, and 3 malicious versions were published. Malware was added to the package that would execute immediately whenever anyone installed one of these 3 versions. So now let's crack open the package and take a look at what actually happened. So this is the package JSON for the package, and we're going to jump in here to the pre-install script. This is basically a technique that almost all malware on NPM uses. It allows this script to run immediately when you install the package. And that /b flag that you see is actually just a little trick to help make the attack a little bit sneakier on Windows. It actually launches the script in a hidden terminal window to make it a little bit more sneaky. So now let's actually take a look at the file there, the script, and see what it's doing. So this is the script that runs. And the first thing you'll notice is it does a different thing on each platform. So Mac users are a bit lucky. Nothing really happens. On Windows, this batch file runs. And on Linux, it calls this function here, terminal Linux, which just launches a shell script. So what does the shell script actually do? Let's take a look. So it starts with this line here, which determines the country that the user is coming from. And it's specifically interested in, is the user coming from Russia, Ukraine, Belarus, or Kazakhstan? And if it's one of these 4 countries, then the script ends early, so it stops running. This is actually a pretty common technique in malware where the attackers, they don't want to antagonize their local law enforcement. So we can probably assume that the attackers come from one of these countries here. So let's say you're not in one of those countries, then the script continues to run. What it does is it checks to see if the file is already executing. If so, it stops. Otherwise, it needs to go download the malware. So that's what it does. It downloads the malware, it makes it executable, and then it runs it. And if you look at the arguments here, you might be able to take a guess at what you think this is actually doing here. This is actually a Monero miner, so the attacker is mining that sweet, sweet cryptocurrency that we all want. So that's the attack. Now, if you look at the Windows script, it's similar, but it has a couple differences. So one difference here is it actually downloads an additional file, a DLL file. And for those of you who aren't Windows experts, just think of it as an executable file. And then it goes ahead and it runs the malware, and it also registers the DLL. And so what's the point of that? That DLL actually steals passwords from 100 different programs, as well as the Windows Credential Manager. So Windows users got a little extra treat from this package. Yikes. So this is the aftermath. So the maintainer, this was caught in about 4 hours by the community because the package has so many downloads. Anyone who installed the package during this 4-hour window, though, was compromised. So any software builds done in projects without a lock file were compromised. Anyone who updated a package, merged a dependabot PR during this time window would have been compromised. So I hope that gives you a taste for kind of what does a supply chain attack look like. But this is really just the tip of the iceberg. There's been about 400 packages removed from NPM in just the last 30 days, and this trend is accelerating. And attackers are really taking advantage of our trusting natures as developers. So here's a real example. This actually happened a few weeks ago. So this is an actual popular package. It's an awesome package. Has 52 million downloads per week. But if you make a typo when installing this, you may install this package by accident. This is a real package from NPM that was published a couple weeks ago, as I mentioned. And if you accidentally did this typo, it would be disaster. So this is what the page looks like if you go to the NPM site. You'll notice it looks like a normal package. Doesn't have too many downloads, but it looks like a reasonable package. But it's not. It's actually malware. So if we use a different tool, this is the product that I'm working on. It's called Socket, socket.dev. And you go to the same package, you'll actually see a whole bunch of really interesting alerts about this package based on analysis of the code. And so you'll see here that we detect it as a typo squat, meaning it's a typo of a much, much, much more popular package. We also detect that it's going to run install scripts automatically, as well as that it's going to run shell commands. And if you click in here to any of these alerts, you can actually see what exactly is it going to do. And so you click in and it takes you straight to the line here, and you can see it's running this child process.exec command. For those of you who know Node.js, you know this is basically running a shell script. And I'll just pull that shell script out there and just show you in a bigger slide here. This is not a command that you want to run, right? This is downloading code from a bit.ly URL and making it executable and then running it. So not something that you really want to run. There's been many of these in the past few months. Here's just a few other supply chain attacks that you may have heard about in the news. There was one in January where a maintainer of Colors.js and Faker.js packages added code to the packages that would denial of service applications in protest of the big corporations using his code for free without paying him. In March, there was a different maintainer who compromised the popular Node IPC package and added code that would delete your hard drive if you installed it, and you happened to be coming from Russia or Belarus. And they did that by overwriting every one of your files with a heart emoji, which is a very friendly thing to do. And finally, throughout March and April, there were many more maintainers who actually did copycat attacks here and added different types of protests to their packages, ranging from redirecting your website to a protest URL and other things like that. So, not something that you want to ship in your production application. So why is this happening now? I think there are 4 main reasons. The first one is kind of obvious. So open source has won. Gone are the days of copying code snippets from Stack Overflow or reinventing the wheel each time by writing everything in-house. We're really relying on open source here. 90% of an app's code comes from open source in the average application. And open source is great. It enables teams to build powerful applications in days or weeks instead of months or years. And it works because anyone can inspect the code. Anyone can contribute. Anyone can publish a package. Open source communities are trusting by default. And good contributors are rewarded with recognition and eventually publish rights. The second reason is that the way we write software has changed. We use dependencies liberally. So that leads to really a lot of transitive dependencies. As an example, if you get started with React and you use create React app to get going, you will install nearly 1,400 packages. So, that's great. I mean, it's a lot of open source. It's like I mentioned before, it's really awesome that open source has won. But each one of those dependencies is a source of risk. It's somebody you have to trust. If we take a look at one real-world app, the Discord application, it's a very popular chat app, and you crack it open. It's an Electron app. It's built on open source packages. You look in their node modules folder, and they have over 19,000 packages. And if you dig into the Git history there, you'll see that those packages come from 300,000 plus contributors, individual contributors, from over 200 countries. So, this app is really built on a mountain of open source. A 2019 Usenix paper found that installing an average NPM package introduces an implicit trust on 79 third-party packages and 39 maintainers. And that's just from installing one average package. So this is a surprisingly large attack surface. This is a really cool visualization that the team at Socket made. This is the Webpack package. And what you see here is every gray box is a package, and we peel back the layers of each package, and you'll see inside there's purple boxes which represent the files that make up that package. And you can see here we're going through the dependency tree for Webpack one layer at a time, and peeling back each package to reveal the files and the packages within, and doing that, going through the whole dependency tree. And you can see just how many files and how many packages make up Webpack. I think this is a really cool visualization. The third reason is that no one really reads the code anymore. We're really just downloading code from the internet, written by unknown individuals that we haven't read, and then we execute it with full permissions on our laptops and our servers where we keep our most important data. It's really a miracle that this system works. It's really quite incredible. I'm sure I'm not the only one who's guilty of merging a Dependabot PR without looking at what code actually changed. Usually I just look at the description and I say, hey, looks good, test pass, merge, and I don't really know what code has actually changed in my application. And say I was, even if I were to try to read the code, and I click through and I look at the code on GitHub, attackers often publish different code to NPM than they do on GitHub. And NPM does not guarantee that the code in an NPM package is the same thing that you would see if you were to go to the GitHub page. So this is pretty worrying. Now, to some extent, we can rely on Linus's law. How many of you have heard of Linus's law before? Yeah, it's a quote from Linus Torvalds of the Linux project, and it goes, "Given enough eyeballs, all bugs are shallow." And what that means is basically, we can rely on the community to find issues in open source code because it's open source. But this is kind of like eventual consistency. There's no guarantee that this is going to be a quick process. And in fact, in this 2020 paper, they found that on average, a malicious package is available for 209 days before it's publicly reported. So that is 209 days during which an unlucky npm install command can end extremely badly. So this is a very long time. A 2021 paper at another security conference found similar results, including that 20% of malware persist in package managers for over 400 days and have more than 1,000 downloads. So this is a pretty pervasive problem. So now I want to go into kind of how does a supply chain attack actually work in practice. We want to see what are the attackers actually doing here. So in the security world, they call this TTPs, tactics, techniques, and procedures. What exactly are the attackers doing here? And I'm going to go over six different techniques here. So the first is hijacked packages. This is the big one. You've probably seen news stories about this in various publications over the years. This is the big headline-grabbing attacks where somebody manages to take over a package and insert their attack code into an existing, very popular package that you might already be using in your project. And this can happen for many different reasons. The most common one is that a maintainer chooses a weak password. This has been the source of many of these attacks. But it can also be for other things, like the maintainer might give access to somebody who turns out to be a malicious actor. The maintainer themselves might become a malicious actor. They could wake up one morning and just decide to blow it all up, right? Maintainers can also use their packages to protest, as we saw in Node IPC that I mentioned earlier, or they could get malware on their laptops. And finally, NPM historically hasn't done a very good job of enforcing 2FA for maintainers of popular packages, though this is starting to change, and they have rolled out enforced two-factor auth for popular package maintainers and packages with a lot of downloads. So that's the first one. So now let's talk about the next one. So typo squatting. This one, I alluded to it earlier. This is another big one. So show of hands. There's these two packages here. Raise your hand if you think that the first package is the authentic package. Okay, raise your hand if you think the second package is the correct package, the authentic package. All right, so most of you got that wrong. It's actually the first package, believe it or not. You would not guess because the name is worse, right? But if you make the mistake and you install the second package, which is a very easy mistake to make, this is the package JSON for that fake package. And if you notice here, again, you see the install script. And what's going to run? Well, this is going to run on your computer. So the file's obfuscated, and even without knowing exactly what this file does, I can guarantee you this is not something that you want to run on your laptop. It's not going to end well. So that's typo squatting. Now let's talk about dependency confusion. So this one is closely related to typo squatting, but it's a bit different. So this happens when a company publishes packages to an internal NPM registry just for their company, but they use a name that hasn't been registered yet on the public NPM registry. And if they do that, then an attacker can come along later and register that public name that's available, and their internal tools might make a mistake and prefer the public package that was published by the attacker instead of their internal package. So that's why it's called dependency confusion. And there's plenty of examples of this on NPM. These are just a few that we found. We don't know for sure these are dependency confusion attacks, but if you look at the names here, these are all packages that were taken down from NPM, and if you look through the contents, there's a lot of malware and a lot of sketchy behavior going on here. And if you look at the names, you can tell they're designed to target different organizations, from Yahoo to URID, 18F, Palantir, DuckDuckGo, Shippo. And these go by all the time. There's so many here. Like there's Wix, Unity, Grubhub. And if you're interested, you can actually go to the Socket website, and in the footer, we have a really handy link called Removed Packages, and you can scroll through those and see what are the packages that are getting taken down from NPM in real time. And you can look through examples just like these and see, okay, why was this taken down? And you can click through the files and try to see if you can identify what is the malicious behavior that's going on. It's actually quite fun. So that's dependency confusion. Now, install scripts. I mentioned this one before. Most malware are inside install scripts. A paper in 2022 found that almost 94% of malicious packages used at least one install script. And unfortunately, install scripts actually have legitimate uses, so it's not really an option to just disable them across the board to solve this problem. This is another example, typical install script here. I'll go into what exactly this one's actually running 3 scripts, and I'll tell you what they do in a second. Okay, now data exfiltration. So this one is very common. Attackers want to steal data. So let's go into that example now. So this is this example of data exfiltration attack. You'll see here the attacker's using 3 different scripts. If we open up the first one, this is a very simple attack here. They're just using the HTTPS library to make a request, and you can see the request here. It's going to this IP address, and what is the data that they're sending? Process.env. So if you see there, it's your environment variables. So that includes like your tokens, your API keys, your secrets. Those are usually in your environment variables. They're collecting those and sending them to the attacker in this request. And I mentioned they were using multiple files, so in case you have a firewall or something that may block that request, they don't want to leave anything to chance, so they've actually implemented a second way of exfiltrating that same data. This one uses the DNS protocol, and they do this by creating a DNS resolver, which is basically a custom DNS server, and they send DNS requests to it, and what they do is they take each environment variable and they use it as the subdomain of a domain, and they do a DNS lookup on it, and that causes that to send a request to the attacker's fake DNS server here. And so this is another way they can collect that data. And finally, data destruction or ransom is a final goal of a lot of attackers here. And as I mentioned, Node IPC did this by replacing all your files with heart emojis. And this is actually the code from Node IPC. So I'm not going to get too much into it. There's a lot going on here, but the most important line is this line right here, where you can see they're writing a heart character over the contents of one of your files, and they do this in a loop and do it for all your files. So not code that you want to run, like I said. Okay, so how can you actually protect your app from all these techniques we've gone over? And this is just a sampling, by the way. There's so many more. But let's talk about concrete things you might do here. So first, let's talk about what won't work, because I see this come up a lot. So vulnerability scanning is something a lot of people talk about, but it's really not enough, or really, it's not a solution to this problem. The entire security industry is really obsessed with scanning for known vulnerabilities because it's something that's easy to do. And it's an approach that's too reactive to stop an active supply chain attack. Because vulnerabilities can take weeks or months to be discovered, and in today's culture of fast development, you might merge a dependency in within days or even hours, especially if you're using tools like Dependabot. So this isn't really enough time for a CVE to be created, for a security researcher to discover this issue, and for it to make its way into these vulnerability scanning tools. We really need something that is faster. And just to be really clear here, let's just make sure we understand the difference between vulnerabilities and supply chain attacks, because they're very different and they need very different solutions. So vulnerabilities are accidentally introduced by maintainers, by the good guys, and they have varying levels of risk. Sometimes it's totally okay to ship a known vulnerability to production, especially if it's low impact or if it's not possible for an attacker to actually exploit it. And even if you have vulnerabilities in production, they might not be discovered by an attacker or exploited before you have a chance to update. So you actually have a little bit of time to address these, and most companies are just currently shipping dozens or hundreds of vulnerabilities in production without any problems so far. So that's vulnerabilities. Now, malware or supply chain attacks, on the other hand, are very different. Malware is intentionally introduced in a package by an attacker, almost never the maintainer, and it will always end badly if you ship that to production. You don't have a few days or weeks to mitigate the issue. You really need to catch it before you install it on your own laptop or send it into production. It's never okay to ship it into production. So a vulnerability scanner will not catch the next supply chain attack. So again, let's go back to how can you actually protect your app? So the first thing, and this is a pretty obvious one, but we should support open source maintainers. I have to mention this because 23% of open source projects have only one developer contributing the bulk of the code. And 94% of the projects have fewer than 10 developers, accounting for more than 90% of the lines of code. So I really think we can do better here. It should be no surprise if you are a maintainer and you're really drowning under the work of all these GitHub issues and all these pull requests that are being sent to your popular project, and you're working on it alone, and somebody comes along and offers you a helping hand and says, I'd love to help you. I would love to, contribute more to this project. It should be no surprise that that maintainer might give commit access or publish access to this helpful person. And we really need to do better so that we don't have maintainers in this situation. The next thing we need to do is really have a mindset shift to change how we think about our dependencies. If you ship code into production, you are responsible for it. It doesn't really matter whether the malware came from your app and you typed it out on your keyboard or you installed it through your dependencies. Either way, in the end, it all gets collected and bundled together and run in the same Node.js process. So third-party code is really your code. It's going to run in your app. And if you actually open up the MIT license, the most popular open source license, you will actually see it literally says this. It says the software is provided as is without warranty of any kind, express or implied. So there is no guarantee that this third-party code is going to do what you want it to do. And we really need to change the way you think about it. Most developers today think if a bug or an issue originates in an open source dependency, that it's not their problem. That just isn't the case. The third thing is we can sort of think about what is the right cadence or pace to update our dependencies at. How frequently should we update our dependencies? Unfortunately, the common security wisdom is to always try to stay on the latest version of a package, but this only increases the risk of supply chain attacks because the quicker that you update your dependencies, the fewer eyeballs that have had a chance to look at the code. Not that many people are looking if you update within a day or two of this new version being published. You can't benefit from herd immunity if you're the first person to catch the virus. So how quickly should you update your dependencies? This is actually a hard question. If you think about it as too slow or too fast, if you update too slow, you're going to be exposed to known vulnerabilities. But if you update too fast, you're going to be exposed to supply chain attacks. And there's really no perfect solution here. There's just trade-offs. I've actually seen one approach from one team where they would try to stay 6 months behind, so there was some time for the community to look at these dependencies, and then to only update when there was an urgent, critical CVE or vulnerability to fix. And that's one idea. But like I said, it's trade-offs, and there's no perfect solution here. Now, this one is, I'm a huge fan of this approach. I think we should really be digging deeper before we choose our dependencies and before we update to new versions of dependencies. So let's talk about kind of how closely should you really audit your dependencies. And again, you can think of this as a scale from full audit all the way to doing nothing. And full audit means literally opening up the package and looking at every line of code of its, every one of its files and every line of code of all the dependencies of that package. And if you do that, it's a lot of work, it's slow, it's expensive, but on the other hand, it's really the gold standard here. It's the best you can do, right? you will catch bad stuff if you do this. You will catch the supply chain attacks. But it's just so much work that almost nobody does this. On the other hand, this is what most of us are doing nothing. This is probably what most of us are doing. And if you do this, you're really just vulnerable to supply chain attacks. It's risky and it's expensive in its own way. If you get hit by one of these, it can be bad PR. It can be expensive to handle the breach that results. So what are we to do here, right? This is a hard problem. What are we going to do here? So I think most of us usually do some things to evaluate a dependency before we select it. There's a few standard things that we usually look at, right? We look at, does the package get the job done? Or does it have an open source license so I could use it at my company? Does it have good docs? Does it have a lot of downloads and GitHub stars? Does it have any recent commits so it's actually actively maintained? And does it have types if you use TypeScript? Maybe you care about that. Does it have tests? So these are a few things you can check pretty easily about a package within a couple minutes before you decide to introduce it. And so probably some of us actually do a few of these things on a regular basis. But I argue this is not enough in 2022. This really doesn't tell you if the package has a supply chain attack in it or it has malware inside. So in 2022, we really need a different checklist. We should be asking deeper questions about the packages that we're using. For example, does the package have an install script? Is it going to run code on your machine right now when you type npm install? And if so, what is it going to do? Does the package have native code? So does it have an executable file inside that's been compiled, and therefore it's hard to audit? It's hard to know what it's going to do. Does it talk to the network? Is this package going to send data to some server? Is it going to run shell commands? Does it read your environment variables and do something with them? Does it gather telemetry? This is actually becoming more common in packages. Does the package phone home? Does it send data about how you're using it, what methods you're calling to the maintainer? And finally, does it contain obfuscated code? Does it contain, nasty code that you can't really figure out what it's doing because it's all been minified and made hard to evaluate? So these aren't things that are as easy to do, right? Even if you wanted to do these things, you're going to have to really do a lot of work and dig in and look at every file. So we really need tooling here to help. So I propose, there's obviously many ways to solve this, but the way that we're doing it at Socket is we've built this cybersecurity platform that protects companies from software supply chain attacks. And we do this by auditing every open source package on NPM. So we've downloaded all of them. We run static analysis to look for these various things that we just mentioned on the last slide. And when we find them in a package, we can tag that package with that issue. And then a customer can use it to evaluate the package that they're considering using before bringing it into their project. So what does that look like? Here's a screenshot of our website. This is totally free. You can use this right now. You can take this back to your teams and tell them about it. This is an absolutely free tool. You can go and type any package in that you're considering using, and you'll get these handy alerts that show up at the top here. This package has 2 alerts, install scripts and native code, as well as some scores that tell you kind of how much you should trust this package and what issues it might have. So in this case, you can look and say, does this package really need an install script? And in this case, this actually does. This is a totally fine package. This one is a good package. You can find that out with about a minute or two of investigation here. But what about a package that's doing something sketchy or untrustworthy? What would that look like? So here's a different package. You can see here, this one has a much lower supply chain security score, and it also has critical issues originating in its dependencies, including install scripts, no README, and telemetry. So if we click that alert, we're taken to this page here where we get the full list of issues present in all of the dependencies. And you'll see that this package is going to run code automatically on installation. It has telemetry. It's going to access the network and a whole host of other issues. It turns out this package is I would say in a gray area. It's gathering a bunch of data about how you use the package and sending it to the maintainer, which might be against your company policy, but this one wasn't quite outright malware. So now what about actual malware? What does that look like? So here's a different package. You'll see it has a score of 0 for security, and it has install scripts, network access, and a bunch of other things. And if we click into the network access or one of these alerts here, what do we get? Well, it jumps us straight to the line where that issue is present. So in this case, the issue is the environment variable access. And you can see here that it's basically collecting the environment variables and sending them off to this server. So not something that you want to install, right? And finally, so this is the kind of last suggestion I have for how do we deal with these attacks. What can you do? The final thing you should consider doing is monitoring your dependency changes using automation. Because it's not enough to just ask your developers at your company to go to the socket and look up packages before they install it. How do you actually guarantee that this is going to happen? And how do you guarantee that this is going to happen for even dependencies that are getting updated to new versions, right? You need automation in that case. So what I recommend is monitoring your PRs for bad dependencies. So you should use static analysis to audit every new dependency and every new version of every dependency to detect when privileged APIs are being used or obfuscated code is added or anything that might raise an alert. And when that's discovered, then a human should come in and audit that package to determine if it's actually malware or not. And I think that this information should go directly into pull requests so that developers can see it and act on it. And so this is exactly what Socket does, right? This is the approach we've taken. So this is the Socket bot. If you install this on your GitHub repository, then you will get a comment that looks like this anytime a suspicious dependency or dependency update is present in that pull request. So in this example here, you can see that the developer installed Bowserify instead of Browserify. So that's a one-letter typo. And I kid you not, this package is actually a Bowser-themed Browserify fork. So if you're a fan of the Nintendo character Bowser, maybe this is the package for you. Although I don't recommend it because it only has, I think, like 300 weekly downloads. So it's not something you want to install. But so you can see here, this is what Socket will warn you about. And here's another example. This is one where the developer has actually added multiple new packages, Node SAS, which has install scripts in it, as well as Next.js, which actually gathers telemetry, believe it or not. So if you're interested in disabling the telemetry in Next, you can do that with this environment variable that we helpfully explained to the developer here. So yeah, that's basically, that's what Socket is, and developers really love Socket. There's a whole bunch of folks that you can find on our website, on our love page, that have said great things about us, and here's a few here you can see. And it's really a tool that doesn't get in the way of developers. It's pretty lightweight, it doesn't send too many alerts, but when it does send you an alert, it's usually something that you really want to know about, and it's something that could be a severe issue. So yeah, give it a try if you're interested. And that's all the time we have for now. So thank you for having me, and I'll see you all around.